Hello, my name is Marc Alric Lim, and I will be presenting my thesis, a rooftop wind turbine energy potential assessment, a case study of the Dante de Poda Hall in the University of the Philippines, Los Baños. To start things off, the data I've requested from Project Sinag is an hourly wind speed at 10 meters, having a duration of 5 years, from the 1st of January 2017 to the 31st of December 2021. The data has been indispensable for my thesis as the project has been able to gather the meteorological data at the specific coordinate my thesis needed, specifically at the rooftop of Dante de Poda Hall. I used the data to determine the feasibility of my topic as the building is a three-story building, which is roughly 10 meters. This is significant because I needed to determine if I could fully conduct my methodology as advised by my guidance committee. Moving on, where did I use the said data? As I've still lacked some key components on my part to fully conduct my methodology, I've only been able to achieve my first objective, which is to gather and characterize wind data parameters using Weibull distribution. But this is more so a confirmation that my topic is feasible. What I did was use MATLAB in order to fit a Weibull distribution onto the hourly histogram of the wind speed and determine the Weibull parameters, namely the shape factor, which determines how the distribution of the wind speed will be, and the scale parameter, which expresses the uniformity of the wind flow. Using those two parameters, I'll be able to then determine the probability density function, the cumulative distribution function, the mean wind speed, the most probable wind speed, and the wind carrying the maximum energy using the formula presented. With that, here are my initial results. Since the meteorological data provided were vectors, I've also been able to plot a wind rose in order to exhibit the direction of the wind speed, which shows that consistency of the wind blowing from one direction for most of the times throughout the year. The probability density function has shown the probability of the wind speed occurring at a given time with the table and the exhibited graph. The cumulative distribution function has shown that a wind turbine having a cut-in speed of 2.5 meters per second and a cut-off speed of 11.5 meters per second will allow the machine to operate 52.28% of the time, given it operates at a height of 10 meters. With this, I've determined the feasibility of my thesis, though not at the exact height my methodology requires, as this is where my progress in the methodology has stopped since I'm still in the process of acquiring the architectural plans of the Dante de Padua Hall. So in the future, how will I use the data provided by Project Sinag? To be further accurate for the wind speed, I would be extrapolating the wind speed data based on the parameters of the architectural plans, then determine the power density and the energy density to better indicate the energy potential of the rooftop using the extrapolated wind speed dataset. A wind turbine will then be selected based on the parameters of average power output, capacity factor, and the annual energy production. I will be having a list of wind turbines, which will then be narrowed down using first by selecting the highest computed capacity factor, which is this one. The rated wind speed and the wind carrying the maximum energy is then used to determine the most suitable wind turbine. With this ends my presentation. Thank you everyone for listening. I also thank Project CNAG for the honor and support and the data provided. Have a nice day, everyone.